Make sure these.
All right, if we're going to solve this system, starting with this first inequality, if I rewrite this a little bit just to model a little bit better the slope-intercept form. If I write my y first, well, I got to keep the inequality symbol pointing in the right direction. So it'd be y is less than or equal to, it'd be 2x plus 3. If I were to graph that based on what I know about linear inequalities, start with a y-intercept of 3, got a slope of 2, so up 2 over 1. Got my 2 points, know those 2 points determine my line. So my line, since this is a linear inequality, would be solid because of the equals bar, right? It's dashed if that equals bar is not there. So drawing my solid line, it looks something like that. Be as accurate as I can there. But with these linear inequalities, we got to consider also the side of the line we're going to shade on. So if you recall, when it's less than, like this one is, we're shading to the low side. We're shading to the low side of where the y-axis is compared to this line. So the low side of the y-axis is over here on this side of the line, meaning when I shade, the shading would go down this direction. I'm being real gradual here because there's more that I have to graph. And ultimately what I'm shading right now is not making up my solution region for my end result. See, I have to consider still this compound inequality. And since I have a compound inequality, what I'm going to do is I'm going to break this up. I'm going to set this up where it's -1 is less than or equal to y. We could also say y is greater than or equal to -1, right, if we turned it around. But since I'm breaking this up, I need to throw a little and statement in there. For this other side, you've got y is less than or equal to 1 minus x. If I rewrite that, it'd be y is less than or equal to -x plus 1, just to model the slope-intercept form. So if I graph those two, starting with y is greater than or equal to -1. Well, greater than or equal to -1 is going to be a horizontal line passing through the y-axis at -1. Put that line in. Oops, let me change that. And if it's greater than or equal to -1, that means we're going to shade above this line, right? So I'll put some gradual marks in here again. And shade above. And ultimately what I'm looking for some overlap here between all these lines I'm drawing. And now I can start to see some overlap between that red and that blue. But now if I graph this final linear inequality of y is less than or equal to -x plus 1, I'll plot my point here on the y-axis at 1. Got a slope of -1, so down 1 over 1, plot my other point. If I draw that line in, oh, hey, that's kind of cute. Not sure why I just did that. But if I draw that line in, we're talking about this being less than or equal to -x plus 1. So less than or equal to would be, this being my purple line here, it'd be everything below, right? That would be the low side of the y-axis and where it's contained with respect to that line. All right, trying to see the overlap here. We can see how these pictures start to get a little busy, right? But if you look closely, the overlap actually forms a little triangle, doesn't it? Forms a little triangle in here.
Where's the third line again?
Third line? third line is this purple line right here. So as you try to make clear all these lines and how they're coming together, you got your purple line, which was the last one we drew. We were shading everything below. We've got this blue line, that was the second one we drew. We're shading everything above. And the red line was the initial one we drew. We were shading everything below. So everything came together right in here. That would make up our solution region. Yeah, questions? Okay, so if we start on this one and notice the first inequality given, it's a compound inequality, kind of like the last example. Makes sense to break this up. If we break this up, we'd have -1 is less than x, and x is less than 3. So kind of like I did on the previous one, if it just makes more sense to you to do this, you could flip this around and say x is greater than -1. Just make sure you're keeping your symbol consistent. We start by graphing those. X is greater than -1. Well, if it's greater than -1, we're talking about a vertical line passing through the x-axis at -1, right? And since it's just greater than, there's no greater than or equal to, it's going to be a dashed line. So here's -1. Draw my dashed line through there. I'll freehand this one because I'm feeling a little more daring. And since we saw how much fun shading all these and putting them all together was on the last one and how that can be a little cluttered, let's wait a minute just to shade that one, okay? Let's look at x is less than 3 first. X is less than 3, similar fashion, it's a vertical line, no equals bar, so a dashed line again passes through the x-axis at 3. We throw that in there. Looks something like this. But now you take this idea of it being an and statement, right? X is falling between these two values. It should make sense when we shade this in, everything goes between those two lines. And if you think about it, if it's greater than -1, well, that'd be everything over this way, right? And if it's less than 3, well, that'd be everything over this way. Any overlap we're going to have is going to occur between those two lines. So right now, trying to build this solution region that's ultimately the answer to these linear inequalities, we've got that much going for us. We've kind of narrowed it down between those two values. So now if you go to the second inequality, I'm going to do a little rearranging here to solve for y so I can put this in a graphing type form. If I solve for y, well, one way I could do it, subtract 2x over. But if I'm going to do it this way and divide everything by -1, I got to remember to flip the symbol. So dividing everything by -1, we've got 2x plus 1 over here. So y is going to be greater than that. So graphing using my slope-intercept form, I go to 1 on the y-axis. I go up 2 over 1. Got my 2 points plotted. I know this has to be a dashed line one more time. And since it's greater than, now that I've got my line here, we'll shade to the higher side of the y-axis and where that's contained. That'd be over here, right? On this side of the line. So if I shade, I'm going up this way. And if I'm looking to highlight the overlap, I want to see where these two regions come together. Looks like the two regions are coming together right in here. So I want to make sure that it's clear I see that overlap. I darken that in to highlight the region, but then I also want to make sure it's clear that those lines are dashed and we actually don't want to contain the points on those lines. All right, so same setup, same goal. We got an absolute value thrown in here, so need to review how that's going to work. Let's start with the one we're probably most comfortable with at this point. y is greater than x. That's already in a graphing form for us because the slope-intercept, well, let's see, the intercept be 0, the slope be 1, right? If you plot your point then for your y-intercept at 0, count off your slope going up 1 over 1. Now, what kind of line do we have here? Dashed, is it solid? It's dashed, right? No equals bar. So I put my dashed line in there. As far as shading goes, which direction are we shading here? Above this line or below this line? Above, because it's greater than, right? So you got to shade to the side that the high side of the y-axis is on. Okay, now going back and considering what to do with this absolute value. At this stage, we really haven't talked a lot about the absolute value function and what that looks like. You know, we may be familiar with the whole V-shape idea. We've seen a few of these. But if you don't recall offhand how that's going to look exactly, what you could do, set up a little XY chart. And what I would do in terms of values I might choose for x here to help me, I would start with a value of x that would make this part right here equal to 0. In other words, it helps me set up some intercepts to start. So if I choose a value for x that's going to make this equal 0, let's choose 3. And then let's work around that value. You know, if I'm going to choose 3, then let's choose some values before 3. Let's choose some values after 3. I know when I plug 3 into this absolute value, what I get back for y, if this was an equation, I'd get 0. But notice what happens when you pick the surrounding values. If I choose 2 now, working my way back, plug in, you got the absolute value of 2 minus 3, which is the absolute value of -1, which is just 1. For those surrounding values, you start to see this pattern, which is why we get this V shape. You know, if you took 4 and plugged in, you get the same thing, right? You're going to get 1 back here. Likewise, if I work my way back to 1, got 1 minus 3, get -2. Absolute value of -2 is just 2. You get the same thing down here if you plugged in 5. So if it helps you use those points for guidance, if I plot those points, 1, 2, 2, 1, 3, 0, 4, 1, and 5, 2, you can see how your V shape is formed. Now, following the same rules we would if we're graphing a line, is this going to be a dashed idea or a solid idea? I don't see an equals bar, so it must be a dashed idea. And then, because it's greater than, we're going to shade inside the V, right? Because that's going to be to the high side. So we'll shade up here. If your objective is to find the solution region, we're going to take the overlap here between the red and the blue. It looks like that overlap is occurring up in here. Do our coloring, we highlight the solution region, we understand points from that region. Any point we choose, if we plug back into either of these inequalities, we'll get true statements back. And if we need to choose some solutions, we can. We just set up our solutions as points. So what's the solution going to be on this one? See, if I come out here to 2 and I go up here to 3, right? 2, 3, that could be a solution. So if I plug 2 and 3 back in, it should work and give me true statements over here.